Okay, so properties of linear relations forms a straight line when graphed. And it can be written in the form y equals mx plus b. Okay, so if you can change it to y equals mx plus b, you know you have a linear relation. So we're focusing today on the straight line. Other relations don't always do this, but for linear relations, they do make a straight line. Now you got to remember there's an exception, right? Like y equals 4 and x equals 2. Those are exceptions. Actually, yeah, x equals 2, those are exceptions. Okay, they actually do make y equals mx plus b, but y is 0, okay, and m is 1. And so that's why sometimes you don't think it can make y equals mx plus b, but in fact it can. Okay, so determine whether or not the following relations are linear. So let's quickly graph that. Okay, how would we graph an equation of this type? Plot the b. What's b? Plus 1. And what do we call that? A y-intercept. So that point will be right here at plus 1. Then we can plot m, or count m. M is 5, which is 5 over 1. What does that tell us? Slope. 5 tells us to up 5, and the 1 tells us right 1. So then you just count 1, 2, 3, 4, 5, 1. There's the other point. Can we make a straight line? Yes, you can. So is this a linear relation? Yes, it is linear. Okay. Now you also know, because it's y equals mx plus b, but I always think we need more practice graphing. Okay. Okay, the next one. This one's a really cool one. You don't need to know this, but it's not linear. Okay, because it's not y equals mx plus b. How would you get the x to the other side? Divide it. So these guys cancel on the left, which is what you want. You're left with y equals 6 divided by x. Okay, you've never seen that before. It's definitely different. Now, you don't need to know this. The graph actually looks like this. Okay, and they have a special name for that. I think it's a hyperbole, is what they call it. Okay, don't need to know that. All you need to know is that you change the equation, so y is by itself. You're marking your test. That means there's no numbers beside it. Okay, it's just plain old y, no numbers. And then you can see that's not y equals mx plus b. The next one, what do you think about that? Do you see this exponent? Yeah, that means it's not linear. Oops. Because it's actually not y equals mx plus b. Okay, it's got that squared part. Now you don't need to know this either, but these ones are called parabolas. They make U shapes. Okay, so those are the U shapes. And I'm going to write down parabola. You don't need to know. That's all for next year. Okay, but different equations can make different types of graphs. What about this one? Is there any squared signs? No. Would you ever be dividing by x? Like b? No, you probably wouldn't. So this one might be linear. Change it right now. Do the algebra. Change it into y equals mx plus b. And then I want you to quickly graph it. So what should we get rid of first? Alex. What do you want to get rid of first? I want to show tons of work here, okay? But what about the -6? You want to get rid of that? How do you get -6 to 0? Pardon me? Yeah, you plus it. Both sides. So you get 5x plus 3y equals 6. How do you get what? So we want the y by itself. Let's get rid of the 5x. How do you get rid of plus 5x, Preet? Minus 5x, good. Okay. And so we have 3y equals, we have minus 5x. What's the sign in front of the 6? Yeah, it's a plus, right? Nothing's changed it, so it's still a plus. What's the last step? Sarah, what do you think? Because we have a number in front of y, so we're timesing by 3. So what's the opposite of times? Good. Okay, so we want to divide this by 3. Now over here, it means we divide this by 3 and that by 3. And so we're going to get y equals -5/3 times x. Okay, so instead of doing it -5x divided by 3, we just divide the numbers and then plus what?
2.
2. Okay, so now you can make your axes. Please graph it real quick. Go. So graph +2. Okay. Now this for this form, it's the exact number and value, right? And y equals mx plus b, it's exactly what you see here. There's no, this does not have to be a subtraction sign. So +2 is exactly +2. Then what do we count?
Down 5 and 3.
Jasmine, what do we count for a slope? And then which direction? Good. So it's 1, 2, 3, 4, 5. 1, 2, 3. And there's our line. Oops, should have gone through the point. Okay. Now you could have graphed it by axes intercepts. But what's the problem with the axes intercept? Look at the number in front of the 5. Sorry, from the x. And when 6 gets moved to the other side, you'd have to divide by 5. 6 divided by 5 is a fraction. I don't really know where that would be on my x-axis. Okay, so that's why it's easier to do slope-intercept. Okay, let's have a look at these. Are these functions, though? Now, this one's linear, right? This one is linear, sorry. You can totally see it's a straight line. And we know that because y equals mx plus b. Is it a function? Are these 4 functions? Real quick, function test.
Yeah.
Straight line. Do they, sorry, vertical line. Do they meet the vertical line test? Use your pencil. All of them. All 4. Do all 4 meet it?
Yeah.
Yep. This one's a function. What about B? Function or not? It actually is, because the way it works out, they get close to the y-axis, but they actually never touch it or cross it. So we do say it's a function. Weird? Don't worry about it. This one, is it a function? Yep. And the last one? Definitely. Hello, Salt. I'm not sure. I just like to be on time rather than 10 minutes late every class. No, I haven't done parents yet. Yeah, I think that'd be good for me if you do that. So, thanks. Sounds good. Well, I warned him last class already, and he's supposed to come for detention. He didn't show up for it. Yeah. Awesome. Yeah, I'll totally do that. I will do that. Thanks. Bye. Okay, so next one. Have a look. Is it linear? Well, what we have to do for this one is we have to check the rate of change. So we have to check the rate of change to see if it is what? Constant, right? If it's constant, that means it's going to make a straight line because our rate of change, the rate of change is your slope. So you're checking to make sure that the slope is the same. If it changed, then you would get an increase or a decrease in the line. So let's have a look. Let's check our y values first. Remember, it's rise over run. So check your y values over your x values. So looking at your y values, what did we go up by from negative 10 to 5? 5. Here, what did we go up by? And did we do the same? And the last one? Okay, so our y values are changing constantly. We're only going up by the same amount. What about our x values now? What are we going up by here? Here. Here. Whoops, I screwed up, sorry. Again, I screwed up. And here, 2. Good. So m equals 5 over 2. It's constant. So then, because the slope isn't changing, we can say it's linear. Okay, so you just got to check the slope and make sure each one has the same slope from one point to the other. Okay, is it a function now? Yeah, it's going to be a function. Okay, there's nothing funny about it. What about the next one? Please graph that super quick. Graph that line right now. X equals 6. Find your 6 value, then graph your line so that all values have that x equals 6. What does that look like? Be quiet. It's a rhetorical question, man. Tony, what does it look like? Yeah, it's a vertical line right here, straight up and down. So, is it linear? Absolutely. Okay. But is it a function? No, because all those points are on the same x. Okay, so it's not a function. There's more than one output. Okay. Okay. So now sometimes we're going to get a sentence like this. A painting is purchased for $10,000. Every year the value of the painting appreciates, which means increases, by 8%. Okay. So the value is related to time. So we're going to have time. At time 0, what's the value of the painting? At 1 year, what's the value of the painting? So what we're going to do here is take 10,000 and times it by 0.08, but really it's going to be 1.08 because you got to add it up, right? Okay, so if you put the 1 in front, that means it's 10,000 plus. What does that equal? 10,800. Okay, number 2. Year 2, it's going to be 10,800 times 1.08. What does that equal?
11,664.
Year 3 is going to be 11664 times 1.08. What does that equal? That's a big number. 13,604.84. Okay, so let me just move that over now. So now we can figure out our rate of change. So this should be the value. I forgot to write that in there.
Isn't day 4 1,300 or 13,000? Because I think day 3 is 12,596.
Oh, you're right too. Sorry, I'm looking at my answers, doing something wrong. Yeah. Yeah, that should be year 4. Thanks, I looked at the wrong line here. 1,
You can do
2.
the same type of question with interest. Just realize that.
Yep, that's exactly right.
I'm
Okay.
just taking planning, so yeah.
Okay, so what you notice here you go up by 800. Here you go up by a lot more. You actually go up by 864. And here you go up by even more, 933.12. Here you're still going up by 1. So is this linear or not? No. Is your rate of change constant? No way. Your rate of change is increasing. Here it's small and there it gets larger. So this is not linear. And the reason why it's not linear is because you're not taking the 8% of the same number. Right? Here we take 8% of that number, but then we take 8% of a larger number, and 8% of an even larger number, and 8% of an even larger number.
Mm-hmm.
Okay, and that's why it's not linear. So this is going to be, if you graph this,
If you graph this as like simple interest, it would be the same thing over and over again. But if it was compound interest, it keeps on going and going.
and this is compound
going.
interest. This is the power of investing, right? So you're making interest on the money you've already earned, and so it gets bigger and bigger. That's why the rich people, I mean, if you got like $1 million, you're earning $20,000 a year, and the next year you're earning interest on that $20,000 a year again. So you're making like $25,000 a year. And then the year after that, you're making like $30,000 a year, right? So you're making more and more each year. So it needs to be rich. Doesn't. That's just sarcasm, folks. Sarcasm. Okay, so just make sure you're clear on that. So this graph is going to be one of those. It's not a straight line, it's curved. You start off small, and all of a sudden it increases more and more and more and more and more. Right? Now, of course, if the artist passes away, what happens? Well, it's probably going to jump up because the value will increase, and then it'll slowly do the same thing, right? Increase more and more and more.
So this graph is not linear.
Definitely not. It's increasing. The slope is changing, and it's getting faster. Okay, now this is extra. You need to know that. And this is what we're expecting to see and be able to tell. Look at the numbers. Look at the next one. Find your rate of change. Go. Find your slope, your rate of change. You can use your slope formula, or you can just do a quick little addition here. So, what would you say? Linear? Really? No, because your rate of change isn't 3/1. It's not 4/1. It's not 5/1. Your rate of change is increasing. Okay, so it's not going to be. Okay, these graphs are the same. This is not linear. Now, appreciation and depreciation are the same, right? You could easily put depreciation in there as well. And that's what your car does when you buy it. That's why you don't buy a new car, folks, because it starts off at a really high value, and guess what? As soon as you drive it off the parking lot, boom, a huge decrease in value. And then used cars usually have a value of about $1,500. Right? That's kind of like the bottom until the car is getting so old it's just falling apart. Then it goes down more and more, right? But you decrease the cost of a new car, so the price of a new car depreciates super fast. Right? I think you lose like 30% in the first year, and then it starts losing less and less and less and less. Yep.
Something also is that it works the opposite, because on the flip side, you take a very old car like a '60s car, and you can actually start restoring it, and then its value can go up and up.
This is true.
And the older your car is, the much cheaper the insurance is.
That's not true.
Well,
once you get collector plates, it's the other way around again, right?
Yes, but there are some interest for restored cars that are actually a lot cheaper than interest for a 17-year-old's perspective, because when you're a 17-year-old and you're trying to get interest, you should expect like $6,000 or something.
Yeah, for sure.
You can do that with a new car too. Like you can upgrade a new car if you wake up twice.
Not always. You could just make it worse too.
Cars are funny. Like houses, yeah, you upgrade a house and it increases in value a lot. But a car, it's because you're wearing it out. I wouldn't really say it. Yeah, it depends what you do. Like if you got a truck and you jack it up, yeah, for sure, right? Wait, so one thing to note here, that it's completely different asking whether it's a function than asking if it's linear or not, right? Linearity doesn't necessarily mean it's a function. Okay? All right, turning over, rates of change. So we've talked about this a little bit, about increasing and decreasing. Okay. But let's have a look. What does the slope actually mean? So the right shows the height in meters of a small wheel-controlled cars. Your slope actually represents your change in your y values over your change in your x values. So this little symbol is called delta. You don't need to know that. And it's the Greek symbol that represents change. Okay. So it's basically
diagonal D.
it's a little triangle. Sorry. Okay, it's a little triangle. Okay. And basically what that means is your rise over your run, right? It's your y1 minus y2 over x1 minus x2. So this is the rate of change, is your slope. Now for this one, the height, the units of height is meters. So for us, it would be y over x, which would equal meters over minutes. Okay, so it's going to be meters per minute, which is your speed. So what we're saying is, it tells us how many meters the plane goes up or down for each minute. Okay, so find the plane's rate of change between B and C. So this would be 0 meters over 2 minutes. Oh, should I just leave that on a test like you guys did and get half marks? No. This equals 0. Okay, so that means there is no change . Okay, so there's no change. Okay. Next, what does the negative rate of change between C and D mean? So here, your y value is 6, and you go to a y value of 4. Okay, so it'd be 6 minus 4. And what would be your x change? 5 to 9, so it'd be 9 minus 4. Oh, I screwed that up completely. Please erase. Okay. So you have to have your finish. Okay, so it's going to be your final height is what? So it's going to be your final minus your start. So it's going to be 4 minus 6. And then it's going to be 9 minus 5. So this gives us a change or a slope of negative 2 over 4, which equals negative 1/2. So what does the negative sign mean? That's right. It means that you're descending. Okay. And that's because there's a decrease. Okay. And it says find the average vertical speed of the plane between A and D. So A is what point? What's the values for A? What's the values for D? A is 0, 0, and D is 9, 4. So you can use your M equation. Okay, so you can take your D values. So your Y would be 4 minus 0 over 9 minus 0, which is 4 meters. in 9 minutes. Okay. Is that in lowest terms? Yep, one's even, one's odd. Good chance they are. Okay, so it's 4 meters in 9 minutes. That means in 9 minutes, you went up and down, so you went up about 4 meters on average. Okay. Next, calculate the change in vertical speed between the plane's first descent to its maximum height and its final descent in the ground. Okay, so its first ascent would be A to B. Okay, and its final descent on ground would be from E to F. All right. So we want to find the slope of AB, and we want to find the slope of EF. Okay. So AB, B is going to be 6 over 3 minus 0, because point A is 0. Oh, let's put this A to B here. Do you guys know why I put the 6 first instead of the 0 first?
It doesn't make a difference. That way you come up with a function.
No, it's because of this thing right here. You always take your final point and subtract the starting point. Okay? So it's your final point minus your start, always. That's why here, which point am I going to put first? I'm going to put F. Right? So here you put your final point and your start point. So when you're doing subtractions. Okay. So this would be 6 over 3, 6 meters over 3 minutes, which is 2 meters per minute. Okay. The 0 is the initial point value from A, right? A's point is 0, 0. Okay. So what's F? F is 0 what? Y value is 0. What's the X value for point F? 15. For E, what is your Y value? And what's your X value? 13. So you're going to get negative 6 over what? Negative 6 over 2. So it's going to be negative 3 meters per minute. Okay.
Could you have just done like doing a little triangle thing on the slope and just finding the points that match the line? So you can do that on that one, but can you do that on all of them?
Sorry, say that again. I was listening.
You know, why is that?
No, I was just looking at my next thing. I have to do.
Like for this one, if you start from say B and you go down to another point that lines up with the line, you just do that, like the rise over run kind of thing?
Yeah, like from C to D,
Yeah.
we would have point D minus point C. Because D was the final spot, we minus
Because we're trying to find.
the speed.
Okay.
We're trying to find, we're finding the slope. Basically, we're finding the slope here, we're finding the slope there. That's what we're doing.
That's what I meant. Like, can you just do the.
Oh, the triangle?
triangle?
Yeah. That's fine
Do that
too.
for everything, or does that just line up randomly on this one?
No, you can do that for everything, for sure. But sometimes we might tell you the values and not give you the graph. But that's pretty rare.
Okay.
Yeah. Okay. So what's the change? What's the change in speed? It looks like that, doesn't it? But you have to ignore the negative sign. Right? The negative sign tells you the direction. So one's going up, one's going down, but the change in speed was only 1 meter per minute. Right? So the negative sign is just telling you the direction. Right? That's a little weird. Does that confuse you? Yes. But you have to ignore it. Because we're going up at 2 meters per minute, and we're going down at 3 meters per minute. Well, there's only difference of 1 meter per minute. The negative sign, you have to ignore the negative sign. It just tells you your direction when you're looking at this graph. Okay. It's a little weird. You guys got that? Okay, so the negative sign is telling you the direction. So if it's a positive slope, what is that telling you? It's you're having an increase in height or in temperature. If you have a negative slope, what are you having? A decrease. Okay. Okay, example number 2. Please read it. And then you have to use your depends on sentence. So blank depends on what? A slow pitch team is hosting a banquet. The caterer charges a setup fee of $500 plus $5 per person. So does the cost depend on the number of people, or do the number of people depend on the cost?
Number of people depending
Oh, really?
on.
So if it's going to cost $500 to have a banquet, you wouldn't go because the cost is too
We're
high?
talking about the $5 cost.
Yeah, no. We're ignoring that. We're looking at your total cost. Okay, so we have total cost. Okay, so your total cost depends on the number of people that attend. So your independent variable is the number of people. And that is going to affect the dependent variable, which is the total cost. What letter should we use for total cost?
C.
Sounds good. Capital C. What about for number of people? And usually we use a lowercase for that, little p. Okay? All right. So read the question again and write the equation. B. Go. Write the equation. So you have a constant and then you have a rate of change. So total cost C equals Tony, what do you think?
C equals 5P plus 500.
You got it.
Does it have to be in that order? Can it be 500 plus 5P?
Use your constant, the one without the variable, is second because that's your y-intercept. Okay. What is the rate of change and what does it represent? Tia, what's the rate of change? $5, and what does it represent? Cost of what? Yeah, the cost per person. In fact, it even says that right in our question, cost per person. Good. What will be the cost if 325 people attend? So now you substitute and solve. So it comes 5 times 325 plus 500. I just did that this morning with the grade 9s. So what is it? Use your calculator. 2175? 2125?
Yeah, 21.
Okay, so $2,125 if that many people attend. All right. Questions? All right. Okay. So identify the domain and range. Which one's X, which one's Y?
The X is the X and the Y.
No, domain and range.
Oh, so main X, range 1.
Are you sure? Yeah. So what's the high and low value for X? What's the high and low value for Y? Go for it. So you're going to rate it as an inequality. Okay, rate it as an inequality. So put the low value on the left, the high value on the right, and then use your inequality signs. What's the high value for the X? Looks like 12. And the high value for the Y? 600. So Y has to be less than or equal to 600, greater than or equal to 0. X has to be less than or equal to 12, greater than or equal to 0. Okay. Now B, what's the rate of change and what does it represent? So now, of course, you know what? Let's do, let's make your rectangle. So your triangle, rather. Okay. So what does M represent? Negative 600 over what? 12? Simplify that. Gonna what?
Negative 50.
Yeah, you totally could. But look, see how easy this is? 600, 12. I got my two numbers right away. Because they're intercepts, it makes it really easy. Yep. Negative 50. Now, what are my units? So, milliliters per second. So, in 1 second, how many milliliters were drunk or swallowed?
Negative or 50.
50. Notice that we ignore the negative sign. Right? We ignore the negative sign. The negative sign is just showing the direction of our line. In 2 seconds, how many milliliters were drunk? 2 seconds, how many milliliters? 100. All right. So you can use your slope to answer those questions. Okay, C, what are the axes intercepts and what do they represent? What's the x-intercept?
Seconds.
No, the values, please. What's your y-intercept? You have to know how to do this. Which one's 0? Read your graph. So for your y-intercept, it's right here. It should be what? 0, 600. Your x-intercept is way down here. That's going to be 12 and 0. So what does this intercept represent?
How long it took?
Yeah. So the time it took to drink. Okay. And the y-intercept, what does that represent?
The amount of water.
The amount of water, or the volume, in this case, the scientific word, volume, when full, or you can even put when the volume that was drunk. Okay. Good. Now write an equation to represent this linear function. This is super easy. Y equals mx plus b. Go for it. You have all the numbers. We just talked about them. So y equals mx plus b. Look on your graph if you want. So you should get negative 50x. We just looked at that. Rate of change. And what's your b value? 600. Now is that a positive or a negative? Positive. So for this equation format, a positive is a positive. Okay, it's not like the other equation format where you have to have subtraction signs. Okay. You guys good to go? Okay. All right.